Lucas, is your team ready? Lucas, are you around?
We are part of Lucas's team. Hi, we are part of Lucas's team.
You're from Lucas' team?
Yeah.
Yes, is Lucas around or is someone representing him?
I think he's around. Or a few of
Okay.
us are.
Okay. So we can start, yes, with your team?
Hi. In your presentation, I saw 3D printing. Is that right?
Yes.
Yeah. Maybe you want to share with us why would you consider 3D printing?
Okay, I think I'll pass on.
What is so unique in the design? Yeah.
Okay, I'll pass on that question to Nau, who is also in this call.
Maybe you put up your slide.
Okay. Sorry, give me a minute.
Yes. Sorry. Yeah, our yeah. So I will just take over for a while. Sorry, was there a question posed before?
The question was, I noticed that you are proposing 3D printing.
Yeah.
Yeah. Can you share with us why was 3D
Why?
printing considered?
Right. So 3D printing is, I think, is not much new to Singapore. Singapore is known to house one of the biggest 3D printer in Southeast Asia, and 3D printing has been gaining a lot of momentum in the build industry. By way of the HDB also championing this 3D printing approach to a new method of construction. I think they have partnered with a company called with the Even Plus Boss to print a room size unit that is entirely 3D printed, and they were quite successful with it. So the authority has been sort of like taking these strides into the 3D printing as a construction process. And what we would like to do as a student is to sort of speculate a bit more further to build upon that and think of how the build industry in Singapore can be changed with 3D printing. And I think if you look through our proposal, so you'll be able to see like some of the benefits that we outlined that are very specific to the 3D printing technology and how it can at sometimes even be better than PBVC, right? Yeah. So that is why 3D printing was one of the main drivers for the project, I would say.
Just to check on this 3D printing, have you all done any research in terms of the readiness of the materials that are available today as far as the structural integrity is concerned?
Yes.
Have you all done any research based so far?
Yeah. We, apart from researching about what is the status quo, what is currently achievable in around the world, we also did a sort of an interview with the Even Plus Boss, the company that I mentioned just now, to know a bit more about what are the challenges that they are currently facing now. So that so in terms of structural, you are right. The 3D printing has always been this issue of they don't know how to include the structural elements to it, and there's quite a few options to do it. With the Even Plus Boss was considering 3D printing as a way of mold making strategy, and then they pour in the traditional concrete and rebar into the holes. So that's one method to solve the structural integrity part. Another is also thinking about how these different parts come together, because 3D printing, if you 3D print a tower, it might fall, but if you 3D print small units that can stack onto the existing structurally sound tower, then it's a totally different approach, right? Because your 3D printing units doesn't have to be compressing on each other, but they can sort of rest on like an existing core system that is already structurally sound, which is also one of the proposal, the scheme for our project, in the sense that there's already an existing core, and then the units are printed on top of the existing slab. So the load that it is taking on is not everything that is on top, but rather like, we might be 1 or 2 stories on top of that also. So that sort of have to circumvent around the concern about 3D printing. Yeah.
Just to share, for 3D printing, currently we will consider maybe for more unique design. So if you are looking for mass production, probably you may
Yes.
not want to consider 3D printing as the first option.
Yes, I'm glad you brought up this idea of customizability, because that is one of the highlight of the proposal. Yes, we are aware that 3D printing will probably not be able to beat PPVC in terms of like manufacturing cookie cutter designs, but if we're to really capitalize on what 3D printing can offer, it is all about achieving and striving for that customizability, which can also be beneficial to the residents also, right? It's quite fun to be able to design your own unit. So yeah, so if you look through our design proposal, we are proposing this idea of self-designing homes, so that we can really leverage on the existing the benefits offered by 3D printing. And in terms of mass production, just to go on using a bit, we are thinking of using these 3D printing robots that can sort of like move around and do their printing on their own. So we are not thinking of having one station that is keep pumping up, but rather having a few small mobile printing stations that can print out units as and when they're on site. So this is a slightly different approach to a factory-like production versus a sort of a swarm of workers working to produce a building. So these two different approaches sort of bring in different aspects to the project as well.
Okay, no other question.
Yeah, Mark here. Actually, just maybe I'll start off with a comment. I think your submission, together with a couple of others amongst the 24 that we are viewing today, presents us, the judges, with a philosophical question in the sense of how do we define or how do we draw the line between entries that are basically making the effort to try to adopt, create proposals that make use or fully maximize of the technologies and the tools that are currently available now, but not yet fully utilized, fully maximized, versus, for example, entries like this that try to push the envelope much further. I mean, it's not just the 3D printing that I think is part of your proposal. I think I saw. I think your columns are made of these. I'm not sure what you call them. The almost like looks like a skeleton or a furling concrete form. What do you call it?
Sorry, is it among our team we call this diagrid columns?
Yeah, the diagrid columns. Yeah, so it's a lot of it is things like that, which are, I mean, of course, at the end of the day, it's student competition. So we, of course, have to try to balance out the imagination component, which I think you guys definitely bring a lot of that here. I mean, you push the envelope quite a bit, and I think some credit definitely needs to be given to that. But how do we weigh that vis-a-vis making it workable based on the tools that are currently being made available now, such as, say, PPVC or MET, or PPVC in concrete or MET or PPVC in steel and so forth. And so I think that's just a line of thinking that maybe I just want to put out there. I think for yourselves as well as for my fellow judges in this competition. I think maybe just another comment. I think you guys maybe did not use the term, but I think when you guys talk about urban farming and things like that, there is, I think there are, in a way, we are seeing hints of this idea of the circular economy, which I think some credit needs to be given to you guys for at least trying to introduce that as part of the conversation about this. Since there's also sustainability component to this competition. And Now, just looking at the overall design, I think you guys started off with two parallel blocks, almost like boomerang shaped on each end of the site, which you then decided to tie together with a series of gardens to, in the end, you basically create almost like a donut shaped building. So I think I'll probably leave it to Owen, who's much more familiar with this. If this donut-shaped building, is it something that allows the building to breathe better, or does it create a more? Is it a building that breathes better, or is it a building that is ultimately creates an internal environment that's probably stuffy? I'm not so sure. So yeah, just some things I want to put out there. Yeah.
I'm Luis here from BCA. I'd like to ask about your evaporating cooling. Because your pool is in the center and your, like Mark has mentioned, is a donut shape. So during the midday, when the pool start heating up, will your building become like a dim sum basket, get heated up, and the humidity level between the central part of the column become like very humid and pose uncomfortable to the occupants? Is there any like analysis on the wing movement or the velocity of the wing that you have analyzed that bring you all to this design?
Yeah, we did. Okay, I guess I will leave the wind part to. Okay, I guess I will just start with the wind part. We did a wind analysis. I think. Okay, let me share my screen real quick. Okay, it's slightly different. So if you look into the appendix of our report, we did the existing. Sorry, it's raining. Let me close the window for a while. Yeah, we did a sort of like an initial analysis of the wind conditions on site, and we find that there is not much pressure difference at the site. As you can see, it is either mostly pale blue, and we are looking for this kind of red and blue combination to promote cross ventilation. So, which means that currently it's not that good. So what can be improved is that we introduce this airwell strategy, because I think I don't need to elaborate on the benefits of airwell. I think there's a lot of studies done, and it has been shown to prove that in terms of sort of tropical climates, airwells sort of have to create this pressure difference that is needed to suck up the air upward. And we have to combine that with the permeability of the building also. So our building is strategically designed in the sense that, as you can see in the illustration, there's a lot of porosity in the facade, so the air can actually flow in from the outside into the airwell, which sort of suck up these humidity issues that might arise from the pool also. Because that is a very good thing that you brought up, the issue of humidity. But if you can see, it is truly open to the air, and it is of a sufficiently large size that it can sort of suck up and create this suction effect that sort of help to improve the air conditions across the units also, because when the hot air in the well rises, it will be pulling in those wind from the outer perimeter, which flow through the units. So it sort of helps to improve the thermal condition inside the units also. Yeah.
Okay, understand that for evaporating cooling to be effective, there have to be a certain velocity that has to be made. Yeah, so is there any analysis on the velocity that you'll be able to achieve to meet this kind of stack effect between the well itself?
In terms of velocity, so this was the initial velocity study that we did, and I think the current situation on site, it is. I wouldn't say. Okay, I'm gonna be honest. I don't know what is the cutoff point to be able to produce this evaporative cooling process that you mentioned just now. But what we know is that there is a very good wind condition on site, and then combined with the proposals that we are pushing forward, we are hoping that this can help to achieve the better thermal condition. But I wouldn't go out on a limb and say that yes, for sure it will work. Yeah, there's uncertainties in our side also. Yeah.
Okay, I think before the proposal and design, I think passive design wise, you have to take note of this consideration. Yeah, no further questions for me.
Sorry, I Owen here. I came late, right? Just I came in and just heard the last part. You were talking about the evaporative cooling, is it?
Yeah.
Yeah. Okay. Can then since somebody has already brought it up. Yep.
Okay, guys, in terms of the platforms that you all are using for your proposal, it seems to be quite a few. What are the interoperability issues that you presume? Because I see that you have used BIM platform ArchiCAD for coming out with your initial design. How does that link to that 3D printing proposal that you are putting up? And could you share a little bit more on that G code that you have in your slide as well?
Right. So that is us thinking about if speculating a little bit on how this if 3D printing were to become the norm in the industry, what is a possible workflow that could be generated? So the future, right now, we are very reliant on this kind of handheld devices. And if we're to pushing forward this idea of customizable homes, what we can say is that we can sort of write custom programs and apps that the user can use it to design their own homes. And this can be transferred to our in-house 3D modeling software, such as Rhino. And what is possible in Rhino right now is this computational BIM approach, whereby the designs in Rhinos can easily be transferred over to ArchiCAD. So this sort of help to bridge the gap between the user designs model into the BIM realm. So after it goes into the BIM realm, there are current BIM, as we know, it can also produce STL files. So STL file, this is the norm that we use for 3D printing softwares. And G code is a type of file that tells the machine, the 3D printing arm, where to go and which areas to move to produce the print. So this helps to bridge the gap from BIM to physical design. So the first part is from user design to BIM. The second half is from BIM to physical design. And there are existing companies on the market like Construction 3D Slicer that sort of help to bridge this gap from BIM to G code already existing. And the G code will be put into the, as I said before, to the 3D printing robot so that it can execute the designs. So from this process design stage, we are speculating that we are sort of acknowledging that these are different hoops that we have to get through and proposing that there are either be existing or very possible solutions on the market that can help bridge those gaps. Yeah.
All right. Time is not on our side. Any last questions?
Just a quick one. How do you ensure your construction timeline for your project, considering that you need to firm up your design for each buyer of your unit before you can print it?
Yeah. So if you can see here, okay, never mind. I'll just keep it quick. Yes. So there's this issue of the user needing to do their own designs. How we solve the problem is that this slide. So there is sort of like parallel process going on in our construction process because as I mentioned before, there is this core structure that has to be built and then the units that comes in. So what happens is that when the users are doing their design process, be it 1 or 2 or 3 years that is used to build the existing core structure, the user will be doing their own design, will be selling out. So hey, you want to buy this plot of land, then they will go and design it, and then there will be a cutoff point whereby the core finish the constructing and when the units can be start to get printed. So this sort of parallel process in the construction process help to reduce the waiting time that you are saying that could result from the homeowners doing our own design. So this is one of the proposals that we're putting forward. Yeah.
Okay.
I hope that answers your question.
All right. So I assume the judges are okay with that.
Yeah.
Great.
Yeah, no other questions.
Thank you, team Studio Somapa,
Thank you. Thank you
for the
for
clarification here.
Thank you.
Thank
Okay,
you.
thanks. So we will proceed with the next team from ITE. Okay, team ITE IBDC 2020 led by Ms. Gu Yi Ting. Can you stand by? Team ITE.
Hello, lecturers. We are from ITE.
Hello. Okay, please unmute yourself so that you can answer the judges' question. Thank you. Judges, take it away.
Hi, team. Yeah, I couldn't find your module size in the presentation. So can you share with us what type of module size the PVC, the DFMA module size that is useful for the transportation and lifting? Yeah, we would like to check whether you have considered, the module size as suitable for transportation and lifting.
Yes, have.
Yeah, what are those sizes?
Wait, so for the PVC height will be not more than 4.5 meter, and the width will be not more than 3.4 meter, and the weight is not more than 80 tons. Does that answer your question?
Okay. The weight definitely shouldn't be that heavy for
Did I hear
lifting.
wrongly? 80
Yeah.
tons?
Yeah.
Not more.
Yeah, it should not be more than, I mean, for 20 ton is already quite heavy. Yeah, so we are working along this like 20, not more than 30. Yeah, it will surely cannot be more than 80. Okay, that's one thing. Yeah, and also I saw that you have mentioned 15 minutes printing time. Too idealistic. I have not seen this.
That is from what I researched.
So you have actually consulted somebody from the industry, is it?
I mean like from the internet.
Sorry? Hello?
So,
Okay, it's okay. Nothing more from DFMA. Thank you.
Sorry, Louis here. For the sustainability part, other than the wind study, is there any other analysis that you all did to contribute to your passive design area?
For this part, actually, to be more environmental friendly and eco-friendly, we create a opening at the bathroom and the middle of and pocket of the building. And LED lines are also inserted to the commercial facade and solar panels on the roof for renewable energy. And we also have a rainwater harvesting system as well.
Okay. Any other technologies that you're thinking of incorporating in this design?
With the green wall system, we provide the green wall system at the different areas of the building, like commercial and residential facade as well. Yeah.
So how does the Owen here? How does the green wall help with everything?
So basically, there are different types of green wall facades that we researched on, and we happen to choose the bio facade. So basically, it's like using generating energy from the algae and the solar thermal heat. And it works pretty well for our apartments because the sun path of our direction has a very good tally with our green wall system.
Are you saying that your green wall system is an algae driven one?
No, I'm not saying it's algae driven, but
Uh,
according to the research, the biofacades are like the system is is generating energy from an existing plant so that it grows.
oh, okay, that's something new to me. I think you need to explain to me how does it derive energy. Because algae driven and then just a bio green wall generating energy is two very, very different things.
So, speaking more on the biofacades, how it works is there'll be a generator or a building which processes the biomass and algae from the moisture. As you know, Singapore is a humid country, so rainwater is very much present almost every month. So that's when you get to generate the energy and all those green plants and everything from that station, which is an
So the,
expensive process, but I think it's doable.
no problem about the expensive. We don't talk about the expensive part first. So the generator, what does it take and what does it do?
What it does is it basically processes the biomass, like I said before, and the algae. It's a very long process, but it's only done in Germany and America, which it processes, like I said, the biomass into energy, which can be transported back into the building to use for your lights, aircon, and basically any
Okay,
electrical
maybe
fixtures.
maybe what chemical process does the generator do?
Chemical
Generator
process.
is a chemical process.
Yep.
Oh, so it will produce what?
So what it does is, yeah, give me a moment.
Yeah, it produces methane, or it produces what? Or it produces algae as a source of fuel.
All right. So
Uh,
what it uses, sorry.
yeah, you go ahead.
All right.
Just want to
So what
understand.
it uses, what renewable energy. So it's how do I say this? It's like it's taken from a nearby combustion process,
So
such as like
it's a combustion process. It's bio. It's burning of
yes,
the. It's burning of the biomass lah.
yeah, exactly.
So where
Then
is where is, so the idea is to the idea of the biomass is to how are you going to get your biomass?
all right. So the first step is obviously from the biomass wall, correct?
Are you going
Then
to trim it every day or
it what it does is it basically renews itself every day or every week depending on how you configure the system to be. This is a relatively new system, so there is still in the midst of testing in Germany and Australia. So for as of now, what we know is it's basically a self-renewable process. As all you need for algae is carbon, basically. So you can take carbon from nearby buildings, especially if they have a boiler
okay
inside or any generators.
okay. I think we can take this. I can ask about this offline. But my question would be: so how much energy is going to compensate? Did you have a
Compensate.
ballpark calculation of how much wall you're going to get off the bio uh the bio wall?
As of right now, I couldn't find exact calculations for the like the energy generated, but from what I saw was it can generate like basic electrical needs for your lights, aircon, that's all.
Aircon? Wow. Then
That's basically what I saw online.
then
From,
BCA, we seriously need to look at this.
but it's like I said, it's a lengthy and expensive process, which is still in testing right now.
I also cannot find anything about this in your report lah. Okay, no more questions from Owen.
Can I just ask a quick question? Your report just says that you use Beam for your IDD. What else did you do to optimize your design?
It means what software we use to process the whole design, is it?
Yeah. Besides using your Revit, what else what kind of other technologies or innovation do you do to optimize your design?
Actually, basically, we mainly use only Revit, Photoshop, and AutoCAD. Yeah, that's all.
What about your, did you translate it, bring it over to do your analysis, your solar analysis and wind analysis or VR, AR?
No.
To check out your design?
We don't have any involved in VR.
Okay, thank you. 5 more minutes.
So do you guys, judges, have any other questions for us that we can probably shed some light on?
Oh, sorry. I was muted. Sorry. Mark here. I wanted to ask if you take a look at the image right there in the middle of your, in the middle of the slide, there are three images, the center image, where the two towers, the two clusters of towers are closest to each other. Can I just maybe just find out a little bit what's the distance between those two?
It's 10 meters.
It's around 10 meters.
I think that's a bit too close. Yeah. I think just some comment. I think in terms of the way you guys broke down the modules for your residential units into PPVC components, I think generally I find that they're actually quite realistic. I think I find them to be quite workable. So I think that's a positive point. But I do think that maybe some practical considerations like what I just pointed out, how close the buildings are to each other and so forth, those probably need to be looked at. Yeah. Other than that, yeah, I don't have anything else here.
All right, I take it that there are no more questions from the judges.
Nope.
No questions.
All right. Thank you.
Thank you.
Thank you, Team ITE.
Thank you.
Thank you. So we will proceed with the next team from NUS, Team Group 16, led by Benjamin Chia. Group 16, are you ready? Please unmute yourself. Thank you. We hear some feedback from someone's microphone.
Hello. Yeah, actually, I'm
Yes.
Joey. I'll be representing Ben lah. Y'all can carry on with the. Oh, we need to share screen,
Okay.
right?
Yes. Let
Yeah,
the
please
judges
share your screen.
start the
Yeah, please
Benjamin,
share
can
your
you share the screen?
Hi, this is Rosa. I'd like to see the part on your PVC plus MET, where you
Okay,
have
one
your
moment.
MET frame. Yeah.
One moment. Okay, can y'all see the screen? Hi.
Yes, can.
Okay.
Okay, so your
Yeah.
MET
Yeah.
plus this one?
Yeah. Okay. Understand that you're using the timber frame.
Yes.
But I like to see how you actually consider the load path. How the load transfer from the upper to the lowest, and if there's any redundancy design, do you consider?
Benjamin or Hui Feng, you want to reply regarding the structural analysis?
One moment, let me open my class. Sorry. That's okay. Sorry, let me share my screen.
Yep, please.
Sorry, the computer is a bit slow.
This is not in the original set of slides, is it? What you are sharing?
I just got a new computer and my desktop doesn't have a microphone. I have to use my old one. So sorry, it's taking a while. I realized I don't have the updated set here. Okay, it has finally loaded. So I'll explain it through my model. Oh my.
You're not sharing screen, no?
Still haven't. Hello?
Yep, go ahead.
Let's crash.
Okay.
Okay. Anyway, if you go through the slides, I'll explain without the window first because I think it's still lagging. Essentially, our design actually consists of a steel superstructure with the MET frames, as you have known. So what happens is each module will capture the load through slats. It will transfer through the MET frames, which will be stacked onto each other. Finally, onto a decking system every 4 floors. Then this truss decking system, the load is transferred through that into a steel core columns. As you can see here, which are both in green line, this image, all the way into the foundations. So I'm sorry for this. I'll go through with you this again later when I have the model loaded.
Any considerations on the redundancy? Should one
With
of the
regards to
members fail? Yeah.
with regards to redundancy, right? Because there is no real in each module itself there is no redundancy other than for fixed connections.
Meaning that if one element fails, the structure may just come down.
So what happens is because of our modular system, right? We have when they are joined together, they are able to provide they are able to provide support for each other. So like you have 4 columns in one area. So when one fails, you technically still have 3 left. Wait, it has finally loaded, sorry.
So you have considered that?
And we do have a low enough utilization ratio for our members in most of our members. But some critical members down it was not considered fully.
Okay, it's okay lah. Then I'll
Can you
let
see
the other
now?
judges ask the question. Yeah.
Oh, sorry.
Can I
sorry.
Oh, sorry, can I just check regarding your DFMA provisions? So you use steel with MET. Can we understand more about the rationale for this choice of materials as compared with, say, if you use concrete, which would be, for instance, much cheaper than this? So why this choice of using steel with MET? Thanks.
As in why steel with MET instead of concrete and MET, is it?
Or even
why
just
MET?
Yeah.
Oh,
yes.
why MET? Okay. So for MET, right, it's actually a relatively new field, especially for Singapore. Maybe in European countries, Western countries, this has been adapted more. The upside of MET right now is that it has a much lower carbon footprint as compared to concrete. As we know, the curing processes in concrete produces a lot of CO2, which is a huge issue in our current concrete jungle of the society. Next is actually the lightweight elements, which is another huge benefit of MET. Of course, this comes with a bit of a structural downsides, which is it has lower strength for bending and other for bending compared to concrete. But all these can be be mitigated through use of through design and also by having for us we adopted more transfer doors, so a higher number of transfer deckings to reduce the loading on each of our MET array.
Okay, it's good that you all have thought about the sustainability, but just from the practical point of view, also MET would be more expensive than other materials, for example, like concrete. So how would you mitigate these cost considerations to make this a commercially, financially viable option? Thanks.
As mentioned earlier, right now the material-wise, yes, MET is more expensive, especially for Singapore because it's new here. But it has savings in terms of weight, which means it increased the workability and constructability of our module system, so we can save through our construction processes.
Okay. Mark here. Hey, just want to ask. First of all, I think I'll start off by saying I think that architecturally the building looks very interesting. Okay, but I think you roughly know where this is going. I think a lot of the questions will boil down to the selection of MET as a material. So let me just get this let me try to understand a little bit better. So the main vertical elements, which are indicated on your diagram as blue, this is a steel structure, is it?
Yes, the blue in the main diagram, the blue stuff are steel, and the hang on, which diagram are you referring?
Yeah. So what is what is included in this vertical? So we're talking about lifts, staircases. These are all part of the steel structure, is it?
Staircases, all this wait, which diagram? The blue arrays you see, or the green one.
Oh, okay. Sorry, in the diagram you just showed now. Sorry, then it looks like
yeah. Can you show the
green.
diagram again?
Steel is green then. Sorry, steel is green.
Sorry,
then
steel is
in that
green. Yes,
diagram.
yeah. Steel is green. Yes.
So that those are lifts, staircases, and services, shafts, I guess, or something. Do I understand correctly?
Yes. There are within our core columns. Then there will also be bracing, right? So those columns will encompass our staircases and also our lift shafts.
Okay.
It's part of the steel superstructure.
But it also means that you will still have a certain number of your columns and beams in MET.
Yes, as you can see, the blue, slightly blue. I'm not sure what color this is.
Okay,
yes,
sure.
Those are the MET arrays. Yes, those will be your beam. There will be beams and columns in those. Yes.
So maybe I just like to ask. Let's say, for example, if there are structural members that are still in MET, what kind of considerations have you guys taken in terms of, for example, fire rating, charring depth, and things like that? In case you have fire or whatever. How do you manage that? Termite protection and such. Yeah. How do we?
Okay. I think I'll answer that one. Because what we have done with our MET modules is that we have given each individual MET modules for the frame an excess of I think it's 750 mm on each side. I can't remember exactly, but it means that our individual modules itself actually has a buffer for the fire protection rating, as well as enough for the fire to burn through the material for a set amount of time. So in that sense, we have actually provided in excess MET materials, so that the fire ratings will actually be within like 2 hours in the case of fire and evacuation.
So did you say 700 mm? So you basically added in an additional 700 mm in dimension. That's actually quite big, of each side for so-called charring depth of for fire protection of the structural members. Is it?
Okay. Hold on. Because the way we have done it is that each of our timber modules are connected by four corners. So we are taking the four corners of the modules as a kind of a whole column. So it's actually, sorry, let me double check how big it is.
Sorry, while you're checking, maybe I'll get another question in. I also noticed that your structure all the way until the ground, the first story, as well as the roof deck of the commercial podium, is also appears to have been done in MET. So how do you manage, for example, contact of the MET members with the ground, particularly water on the ground, as well as, for example, if you have landscaping that is directly on the rooftop of your podium, how do you manage containing soil, water for irrigation of your plants, and so on and so forth? How is all of this managed as part of the overall MET system?
Okay, so on top of our timber modules, once it hits the ground, it has actually raised. So it's not actually directly interfacing with the ground itself. There's actually a concrete slab above the ground level for the timber to actually sit on. So the timber modules itself is not touching the ground itself. So at the ground level, only the steel members are touching the ground.
And then the rooftop podium with the landscaping, how do we manage this?
So on the flip side, the rooftop surface, because there's so, similarly, it's not the timber that's directly touching the stalls. There'll be a layer of protection and vapor membrane before we actually have the kind of more moist materials on top of the roof.
So fundamentally, what is still supporting structurally the podium roof is still MET. Let's say, for example, the swimming pool of this condominium, or all of this, the structure that supports the soil depth for the planting, all of this is still fundamentally MET, except that you've added in, what you're saying is you've added in a layer of something?
Yes. So individually, the modules actually provide in excess of structure stability. So because of the module dimensions, it is enough. Based on what we have seen, is enough for it to support a certain amount of weight and load on top of it. Yes, majority of the weight for that level that you're referring to will be supported by the MET and not the steel structure. But the idea is that by using the modules directly on top of each other, the load transfer of it will be carried down by the MET modules into the metal frame.
Okay. Yeah, I think though your faith in the MET material is definitely admirable. I feel that it's probably not necessarily to be so purist about it. Yeah, I'll leave it to the other judges. Thanks.
Okay,
Thanks.
Owen here.
Right.
Okay, I join Mark in saying that the form is very, very interesting, and I applaud the attempt to stretch the MET. I personally like the material of the MET, and I think the various questions that has been asked do demonstrate that a lot more needs to be included in your design for the MET. I don't have a question for you guys because I think the fundamental question here is, does MET work in such a format in our environment as well as in our current regulation? Can I just understand? I was been trying to run through all your slides. Do you have floor plans? I don't seem to see floor plans in your slides. Oh, this is the poster, is it? This is the A1 size poster, is it? It's not inside your slides, Yeah, okay. Other than your analysis for the MET overhang for both water and sun shading, what other sustainability things did you consider?
Hi, Joey here. So we actually looking at the wind analysis. So you're just saying that we only raised two, right? The sun shading and the rain, right? So we actually did wind analysis also to benchmark with the other possible forms that we can come out with lah. So I think the overall focus of the sustainable part is we're trying to see how an slanted facade will actually improve the overall environmental performance in these different sectors. So for the wind, right, one thing we noticed was we actually mainly use pressure differences to calculate the wind. So as you can see from, let me share my slide. Okay, sorry, Keith, right? Okay, can you, okay, so what I did was actually I used flow design to compare a flat facade with the overhangs. So if you look at the normal flat facade, right, what we notice for all the different kind of facade is the pressure on the flat facade is typically low pressure. Low pressure, yes. And the pressure on the horizontal facade is, you can see that it's much higher in pressure as compared to the flat facade. So from this actually.
Sorry, I interrupt for a while. No, I saw this. My bad. I meant to say the rain, water, and sun. But what other things did you all consider? Sorry, my bad.
Okay, sorry to interrupt as well. We are also running on time, so I guess it should be last question.
Okay, so we did the daylighting, the solar radiation, the rain, and also the wind. So we did 4 lah. So the daylighting was mostly focused on how. So initially we were afraid that if the overhang is too long, the amount of light that enters into the depth of the building might not be sufficient. So actually we did a benchmark against all the different possible iterations, and we noticed that actually the daylighting that enters the room for the longer overhangs are still within a comfortable lux level lah. Yeah, and then from there, actually, what we noticed was that from this daylight radiation, daylight analysis, we also noticed that for the sun is actually shining on a double slab for the flat facade. That means the sun is shining on all the double slab for the flat facade. But for the longer facade, for the longer angle facade, right, the sunlight is concentrated on a single thickness overhang. So I think in terms of, so as mentioned by my friend, I think there's a lot of concrete and other materials within the flooring of each facade, of each module. So I think the amount of material exposure is also minimized if we use a much longer overhang. Yes. I hope that answers your question.
Okay, thanks.
Thank you, team group 16. We will proceed to the next team from Republic Polytechnic, Team Oasis Jam.
Hi, judges. Hello.
Yeah,
Hello.
Okay, just to start off with the question on what is your proposal for the implementation of the concept of integrated digital delivery across the project delivery lifecycle, like all the way from
Can I share
design?
my screen first? Can I share my
Sure.
screen?
Go ahead.
Okay, sure. So, can you see my screen?
Yes.
Okay. Sorry. What's your question?
Right. So I was just trying to ask, what is your proposal for the implementation of the concept of IDD across the different stages of the project lifecycle, all the way from design, construction, fabrication, and also the slide that you're showing just now, this project use case of the project refinery. So once you had these unlimited options, right, how did you come out with the most optimal option to proceed ahead with?
What we did for this refinery, first of all, let me tell you a storyline. First of all, we went to we look at the hotel, Oasia Hotel. There is a fantastic design. Then we have come up with one idea. Why don't we build 4 such buildings and combine them together? Yeah, because we like the L-shaped design, and with those basic concepts, right? Then we add in the parameters into this refinery app. Then it will generate many models, and the models will also form in a 3D model in Revit and Dynamo. Then another student, Henry, he will throw these models into those simulation app and look at the simulations. Then form a relationship between the different models and the relation and the analysis results, and see whether there's a link, and look at which one we prefer. Look at all the data and select the preferred choices. Yeah, if you would like to know more, I will pass to Henry to elaborate more because he's in charge of this.
Right. Can you elaborate a little bit more on what are those relationships and the data sets that you consider to come out with the final options?
Yeah, one of the relationship, because when we doing the refinery, right? This is one of the. Can you see my cursor? This is one of the more preferred model. During in the refinery, the four towers are not fixed. It's adjustable based on the parameters, and like we show this let's say shadow analysis. Different model, it will have a different shadow analysis result, and which we may not prefer because our planning is to form a staggered arrangement, and with the help of the 4 towers, right, you add like a shading device to other towers, like provide a shading area. But if we look at the data which we are not satisfied, then we will continue this process. Yeah.
Okay, and the first part of the question was, I mean, what's your proposal for implementation of IDD across the different stages? So this is maybe the design stage or maybe the conceptual design stages. What did you use, the technologies or the other stages?
This is the design stage. Then besides that, then we look into the PPVC. Yeah, we have 9 PPVC modules for residential, which is shown here. And when we are designing this PPVC, we use Navisworks. We use the clash detection. because it's very convenient. Your Revit, your architecture model, your MEP model, we detect for the clashes, like all the 9 models together in a file, with the different template. Yeah. Then my teammate will just adjust the file accordingly in the Revit side. So it will definitely help and save time. Yeah. Next word, clash detection, individually and overall clash detection for the whole building.
Hi, Rose here. On your 9 types, I saw that actually there's mirror image. That means once the design is handed, it's with the mirror image. It's not the same type anymore. Yeah. So instead of 9, it could be 9 times 2 lah, 18 types lah. Because once it's a mirror image, it is not the same. Yeah. And for your commercial steel PVC, I saw that you have a height of 4 meters. Yeah, I think the 4 meters is actually too high. If you are putting onto the low bed trailers, too high for the transportation. Yeah, I think it should be about 3.6.
But I think we according to the guide, and yeah, it not exceed 4 meters, so we assume that 4 meters is acceptable. But yeah, we should be research more.
All right.
Yes.
Thank you.
Yes.
Can I
No other
just
questions from me?
okay, Owen here. I'm just looking at the floor plan. I'm not the floor plan residential. Typical floor. I'm not sure what slide number it is. But if you look at your general floor plan, right? I'm not an expert of DFMA. But it looks like your are the gray areas modular?
Yes.
Okay, the color areas are PBBC lah. So
To be honest, to be honest.
So my question, let me ask my question first. So
sure.
your first question I have is all those gray areas, how you good? What is the construction format of the gray areas? That's number one. And then I go back to your okay. I like the idea of a farm inside your project is aquaponics. I also see that you have made calculation of the amount that is your yield in terms of veggie and protein, which is your fish. And also good that you all generally calculated the energy required. Just a comment. Looking at the layout and your perspective, you have to be very careful of how much sunlight you are going to get, because I'm looking at your different vegetables. These are high intensive and these plants that you are talking about here requires a high amount of direct sunlight. You are looking at about 12 hours minimum each day. So you have to be very careful of where you put and how you lay out the plants. Looking at your floor plan here, some of your inner layered plants might not be able to get enough sunlight. You know, things like kale or basil, these require a lot of energy. So perhaps you need to look at this very carefully. And can I know which floor is this at? Or Sky Garden? Yeah. So you got an opportunity here, lah. Then maybe to the first question itself.
Yes. So I'm going to answer your question.
Yep. Please.
Okay. Okay. So first of all, just now you mentioned about the gray area of the residential floor plan. To be honest, the gray area we did not manage to transform it into a PVC module. Yeah. To be honest, we have think about it to investigate on how we are going to solve this issue. For the living room, for example, maybe we can separate them into different parts and form another new module. But be honest, we did the calculation, and if we do it this way, it's no point to implement on PVC option if we have so many modules together. Yeah.
No, I understand that. So perhaps maybe Mark and Rose can have a can give a
yeah.
I think
Actually,
Mark, what am I getting at, right, Mark?
Yes. I think
Yeah, understand.
I let the ladies first.
Yeah, because for PPVC, we would like you to achieve at least 65% of the floor areas having PPVC. 65%.
We only managed to achieve 50.55%.
Which means
So not there yet.
Yeah. So which means that if you're able to achieve able to so-called achieve PPVC usage for the living dining rooms, as what Owen has pointed out, I think it will take you over the line. Anyway, actually, how do you say? I would probably not design your residential units the way that you have. However, what I think you probably can deserve a little bit of praise on is basically, I think that the general concept is something that can be massaged to basically achieve a PPVC friendly layout. So I think it's something wherein if you were probably given a little bit more time to maybe have a few goes at it, I think eventually the layout looks to me like it can be refined until you can cross the 65% line and even provide PPVC components for your living dining room. I think maybe the what I find a bit unusual about your scheme, if you take a look at, I think it's your 1, 2, 3, 4, fifth slide. Can you go to the fifth slide?
What is it about?
The one with the location plan.
Location plan.
You have a slide with the location plan, and slide number 4. Yes. If you take a look at it, actually, you see it's very, very clear here on the plan that you have on the right-hand side. There are 4 towers, right? And each tower appears to have an appendage, a tail. And I took a look at your floor plans. It looks to me that like that is your lift core and your scissor staircase. Is there a reason why you actually designed your tower this way?
Do you mean the arrangement or?
Yeah, I mean, why do you have like a small little bridge that goes out to a lift core with a staircase?
Small little bridge. You mean the bridge on the Sky Garden or the?
Okay, maybe you go to slide number 6.
Oh, you mean the gap? You mean the gap?
Can you go to slide number 6? I think it's easier to see over there. Yeah, okay. So if you take a look at, let's say, floor plan for residential, the plan on the upper left-hand corner, you have a scissor staircase there on the lift. It's like pulled out as a completely separate element from the rest of the building. Is there a reason why you did that?
Sorry, I don't really get your question. So why do we use a staircase or?
No. Why is the staircase like appears to be completely separate from the rest of the building and the lift? Yeah.
Okay. The reason is, we're trying to use the staircase as a shading device, like to block away the direct sunlight, to block away maybe 40% of the direct sunlight to enter the residential building. And we did analysis, the solar analysis below. It works. If you look at the east side, this scissor staircase, it will efficiently block away the up to 40 to 60% of the direct sunlight.
But okay, can you go back to the slide number 4, I think?
Yeah. Slide number 4. Yeah, here.
Okay. Now, if you take a look at it, the block, I'm referring to the site plan, which is on the right-hand side of your slide, right?
Yes.
So if you take a look at the block that is on the upper left-hand side, you can see that your scissor staircase is facing the west view, right? Am I correct to say this?
Yes.
And the block that is on the lower right-hand corner applies the same principle, but to the eastern sun. Right? However, the blocks that are on the upper right-hand corner and at the lower left-hand corner do not do this. So
yes.
So in a way, there's a little bit of inconsistency in the logic there. That's number 1. Number 2, I think that I don't think it is necessary to do this. All you need to do is reconfigure the unit layouts such that you avoid the windows of your bedrooms and your living dining rooms to face the east and the west side. And I think that you'll be able to solve that problem. Yeah. Okay, yeah, but that's about it, lah. I think, yeah. That's it, thanks.
Yes. Any more questions?
Yeah, I'm Luis here. I was looking
hi.
at your report. You are stating that your project is using screw chiller for the commercial part. Any reasons for that?
Maybe I pass this to my NEP friend, Henry or Jinan. Hello.
Hi. Yeah. So in your report, you stated that you are you are proposing to use a screw chiller. Is there any particular reason for that? Because I believe the tonnage is not that low, and using a screw chiller would be more inefficient as compared to a magnetic multi-compressor chiller or probably a centrifugal chiller.
I think for the chiller plant, I think to be honest, we didn't really focus so much on it, but we did of course we did the heating and cooling load, and based on that report, I think they figure out with to choose a screw chiller, but to be honest, I think we need to make improvement on this part. Yeah.
Okay, understand. Any consideration on extending the chilled water usage to the residential component as well?
You mean the chilled water for residential?
That means they have a centralized chiller plant providing chilled water for the commercial as well as the residential. Any so-called like, do you have any consideration on that, or you have considered before and you think that it's not feasible or something? Yeah. Any considerations?
Yeah, actually we discussed before, and as we know, the chilled water is mostly for HVAC. Yeah, and it's mostly meant for commercial. And our residential unit, we decide to use a split unit, and that might not be that suitable to include the chilled water to use it in the residential part of the plant. Yeah.
Why is that so?
Because
in Tengah, they are proposing using of district cooling for residential part. So for your standalone building, what is the consideration that you all have been discussed to come to a conclusion on that?
Maybe when we doing this project, we didn't have such a big picture, but we just consider about some basic things about how the residential pay their utility bill, how they configure their split units, and if I'm not very sure about if the residential part use about the chiller plant and how will they going to configure it, but in a simple sense, we just feel that we just make it easy by using the split unit, or maybe as what you say, if they use the chiller plant water, that definitely have their reasons, and I think we should really should invest more on it. Yeah.
Okay, can.
Hi, I'm just looking at there's a chat over here. Somebody said that you're using the image of your computational refinery from their blog.
Refinery.
I think if you look at the chat that is now online, did you take this from somewhere else, or is this generated from your own?
You mean the chat? Okay. In this chat?
The meeting chat, BCA BIM Studio guest.
Yeah.
Okay, trying to open it.
Just to you can look at the meeting chat. There is
yeah, sure.
There is a posting there.
I think the image is just to as a part of the decoration of our slides. But yeah.
I think
As-
your slide should be showing things that is generated from
No,
your.
no. Sorry, Georgia. It is generated for our for our project. Sorry. Can you repeat your question again? Yeah, just now I'm busy
No,
looking about the
somebody is
chat
saying
window.
that you took
Yeah.
this picture from their blog. So is that correct?
From their blog.
Yeah.
Dynamo Screen. Not really. But we did a space planning in Dynamo that is much very related to our floor plan design. Yeah.
I'm looking at your slide. It's exactly the same.
How about showing our work in our refinery? Because I think we put a picture just for reference.
No, I think, Georgia, you are trying to say that the model that we generate at here is not exactly what we similar to our project model, right?
Yeah, the picture that you have shown, is it from your model, or did you take it from somewhere else?
No, this one we did it by our own. We generate it as I think I elaborate it in the initial part of this presentation. This model is just in the initial stage. We used it. We have ideas. We put in all the parameters and we generate this model, and it's for a simple analysis purpose. Then when we move on, we will start to draw with Revit and come out and so on. We come up with a final model. So this model is definitely is our work. We did it, but this model may not look like the final product because we just use it as an initial design process. Yeah.
I understand.
I would like to add that the one on the left side is done by us. However, the right side is what we make for is what we use for reference, and we acknowledge his work. Yes.
Okay. So okay. If you're gonna use a picture from someone's blog, you should at least put a reference to it, because otherwise we think that it is something that you did.
Yes.
Yes, we apologize for this.
For any of your photos and pictures, if it's something that you take off from anywhere, you have to put a reference, because you can't pass it off. I mean, you can say that it's a reference, but you have to reference it.
Yeah.
Okay. Thank you.
Sorry about it. Yes.
All right, we have to move on.
Sure.
Okay, we have overrun really.
Yeah. So thank you.
Okay, thank you, team. Oasis Gem.
Yeah.
So the next team will be from NUS, Team RV Consultants. Nicholas Neo is the team leader, so please get your teams ready. Team member ready. Thank you.
Hi, good afternoon to everyone.
I actually have no access to your slides or your video at all.
Oh. Who is speaking?
It has. I have. The access is all restricted.
Oh.
Yeah, I could not access as well.
I'm not sure if the rest of the other people can.
Yeah.
Yeah, neither can
We had
I.
this problem. Yeah, that's why I
access.
feedback to.
Yeah, I also
but
cannot.
anyway, maybe the team can explain to us what is this about. Give a brief sharing. Can?
Okay. I will. How about I let my team architects share more about their design intent. Just to check, are the judges able to access the slides and poster, or it's just unique to the video?
No.
No, we
there's no
go into
slides.
the entire folder.
No
Yeah.
materials were
There's no slides. So what I managed to see after the organizer has sent to me is actually a video. Yeah. So maybe you can just share with us, or you want to share your screen now, and then quickly go through what is your proposal for the few parts like DFMA, IDD, and green.
Okay, I shall share the screen. Okay, just very quickly I'll just quickly run through the slides. So on the team chart, this is our team chart. We have 6 members and then 2 each from civil, architecture, and mechanical. And this is our slide analysis. And, we use Grasshopper to do parametric design on the building form. And this couple of slides summarizes our design features. Centralized air conditioning is also used to reduce electricity usage. Finally, we have used DFMA applications in terms of our building design. So we adopted standard sizes like, as in standard to a project, like 3x6 and 3x9 meter modules. And then this is a picture of our PPVC module, which summarizes like how we fit out the module with mechanical fittings and all, such that it can be placed on site, and then we will reduce on-site work. Virtual reality is also used to visualize certain things that can't be replicated as well in other programs like Revit. And then it also illustrates how we use how is the iterative process of design. And the IDD portion just summarizes like how we manage to collaborate using available online tools. Microsoft Project was used for construction scheduling. And then these few slides are on simulation and analysis. CFD. And then here's a picture on Navisworks and how we use clash detection to find clashes between structural and MEP fields.
Nicholas, I think the
slide
is refreshing.
Oh, okay. My bad. Yeah.
Yeah, we are still stuck in the virtual reality.
Oh no. Okay, but essentially, that is it. I think we need to find a way to sort out the slides such that the judges can view it, because I feel it's a bit wasted if we don't share our effort properly, like communicate our effort properly to the judges. Would you want me to run through the poster very quickly and the report?
Yeah, that might be faster if you just go through the poster, yeah.
Okay.
Yeah, go through the poster lah.
Okay, I'm not sure if you can see the poster on my screen right now.
No, you must unshare and share again.
Okay. Okay, so this is our first of 4 poster pages, which summarizes like our how the process of design
Nicholas,
was.
the thing's not loading yet.
Yeah,
Okay.
your files are big. Yeah.
Yeah, it's a huge poster file. I apologize for that.
Nicholas, do you want me to share instead?
Oh, yes, Shaman can take over from here.
Okay. Can you all see my screen right now?
Yes.
Yep.
Okay, we are on the poster now.
Should I just run through the slides again, or should we share the videos with the judges? And then after that, because from what we heard, the judges couldn't see the video and everything that we upload at all. Was that right?
Yeah, maybe you go through quickly.
Yeah.
Okay. We'll just go through quickly. So this is our project. First of all, for the design stage, we analyzed the site and we generated our form by the aiming to make our building sustainable, judging from the wind direction and the sunlight direction, and plus the sustainable designs that we added in. And then after that, this is the software we used for civil engineering and mechanical engineering. And then this are the information on our DFMA modules. The PPVC modules, where we have 8 module types and 4 different floor plans that are stacked together to create our current form. 3 towers are on our design. And then this one is a detailed picture of our PPVC module. And then these are some of the sustainable features we have. Solar panels, pre-solar design to reduce heating from direct sunlight, perforated facade panels, eco garden, and Bernoulli funnel, which is step ventilation. And then finally, the one night rendering. Should I go through the slides as well? Because just now, Nicholas' screen was lagging, and a lot of the slides weren't really...
Go through quickly lah.
Okay, so this is us. This is our roles and responsibilities team chart. And then some of our key concepts, how we generated our design, and our sustainable features, eco garden, solar panels, grey water recycling, centralized air conditioning, and then our DFMA modules, 8 types and 4 different floor plans. To improve efficiency, these are the structural details, and then our PPVC module, the exploded, the 3D model. This is the MEP system, the virtual reality that we make use of to enable visualization and lighting visualization. And then for IBD, we use this software for sharing of information and also models. And then for digital construction, we also we use Microsoft Project to analyze the construction program. Then finally, some simulations we done on SketchUp and Revit. Sunlight and I think wind and sun also done already. Sun paths and solar radiation and ventilation. And this one is how we find the clashes. Yeah, and then this one is our workflow. Then we use Microsoft Teams and Google Drive to share our products. And then finally we use Zoom also. And then these are the key challenges and what we learned. And then that's about it. Is that okay? Or should we? Is that okay? how should we make sure that we send over the video and everything? So then after that, we go through again.
On my part, I think it's quite an unfortunate incident that this has happened. Then I was thinking whether, like, I'm not sure how productive this session will be.
Because there's not enough time for me to elaborate on everything, and there are other parts that's done by other members that, yeah, need to be elaborated further as well in the video and in the presentation.
Can we get some guidance from perhaps Ms. Junita or the judges on what we can do from here?
What we can do is we actually have your link, but I guess it's the some can actually view, but I guess some needs permission, I think. We can deliberate later on during the end of the session when we can open up your files again.
Okay. But I would like to just add in that my team is ready to share and like defend our submission anytime.
Yes, of course. Judges, any input?
Separately on the issue?
Other judges, based on the thing, any questions?
I think, okay, just to get the ball rolling. After you basically placed, because I noticed on your site plan, you guys have like 3 square-shaped tower blocks. Are you able to explain your rationale based on that, or if you've done any analysis after you placed them in that position? You probably did some analysis for solar, wind, or whatever, and other considerations. I don't know, pedestrian circulation and so forth. And why and how did you arrive at this point?
Okay, let me share my screen. To elaborate on that, we can look at this key concept diagram. So first of all, why we generated the 3 tower blocks is because we didn't want every level to be too dense. We want the residential rooms to be split up so that the air, the natural ventilation and air can ventilate the rooms. So we did analysis on.
No, but let's say, did you run some simulations on it in terms of performance to solar, wind, and so forth, and then from there adjust it further, or that sort of thing? Let's say, for example, here, if you take a look at the diagram that you have on the right-hand side, the towers appear to be oriented almost true north-south, but the actual final outcome is actually different. Is there a reason for this?
We wanted to leave gaps for the wind to pass through from north to south, and then we also oriented the windows to be not facing directly to the east and west, where the afternoon and morning sun are strong. And then after that, we also want the PPVC module, the rooms, the houses, to get as much natural sunlight and ventilation as possible. That's why we split them up into 3 towers. And then after that, we adjusted them by adjusting the height of each building so that the wind can pass through more freely and some direct sunlight can be blocked by the buildings.
No, actually, I think this diagram is a very good illustration, because the diagram you have on the left-hand side appears to show 3 blocks that are oriented true north-south.
Yes.
Then we take a look at the tower on the 3D diagram on the right-hand side, where we see that the towers have been reoriented almost to follow the orientation of the street. So,
Yes.
so the reason is because of wind. Is there any wind study to show that you've to justify why it's better to orient the towers facing the street rather than in a true north-south orientation?
This one is done by our civil engineering friends. Do y'all want to explain on this? Anyone?
And maybe also just to follow up to that, let's say for example, if you take a look at your diagram on the right-hand side, the tower in the middle is shorter in height, as you mentioned. Is there a reason why it has to be that tower rather than the one on the left or on the right? And what are the criteria? And maybe you can talk about the IDD studies that you have done to come to these so-called design decisions.
This one, is there anyone? Stacy, you wanna add?
Actually, the reason that we place in in this orientation is because to allow the wind to pass through from the north to south direction, which is shown in the CFD. Yeah, and also the reason why we make it of different height is also that we intend it to allow the towers to be able to provide some shading, especially in the afternoon. Yeah, that explains our the orientation and also the layout for the plan. Yeah, and yeah, and for simulation wise, I think we might not have look much into the simulation, especially after our design. Yeah, but the thing that we did is to also to add a balcony, which is like a green area to allow for buffering from the direct sunlight to the building itself. Yeah, so to prevent overheating for the building, especially for the afternoon sun. Yeah, and to allow the our design to be cool, especially in the afternoon. Yeah, hope that answer your question.
Owen here. Other than the wind and the sun, what other sustainability consideration did y'all do?
Okay, so for sustainable features, first of all, for all the windows, we had this design brise soleil to shield off the sunlight to shade the direct sunlight and reduce heat gain from the solar radiation. And also we did the SandPass analysis to make sure that inside the rooms there are as little direct sunlight as possible, so it reduces need for air conditioning. And secondly,
sorry, I interrupt. Sorry, I mentioned other than your wind and sun, what other did you do? Because I can already see what just now you already did it, and I can also see how that transformed a little bit on the design. But what other things did you guys consider?
Louis here. Maybe I write on to Owen's question. Is there any technologies that you use that improve the energy efficiency of your building itself?
Okay, for that we used first of all solar panels on the top of on the roof of the building, and it generates this much of electricity annually to power all the LED lights along common corridors, lobbies, and green spaces. And then secondly, we also have MEP technology of gray water recycling, we can recycle the wastewater from toilets and kitchens, wasted waters, to collect them, process and clean them to use to water the water for to water the greeneries, and also centralized air conditioning to improve the efficiency of electricity instead of having individual room air conditioners. And then after that will be DFMA modules. And also to improve efficiency, we used slim floor for the civil engineering part, and also connections to enable fast and secure assembly. For MEP and civils, do y'all want to add on for these points, or the technologies that y'all used?
Yes, Nicole here. I'm from the ME team, and we use a centralized cooling that consists of water-cooled chillers that are more efficient than the normal split type units commonly used in households. This could save us roughly about 30% of the energy usage. And the benefits of this at this point of time is also that the water-cooled chillers can be drawn to each individual residential unit, and within this residential unit we can have another processor to use this chilled water and process it into the cooled air, and this also reduces the chance of like the spreading of virus within separate household units. And to add on the grey water harvesting, we can also collect rainwater, and all these are all drain and lead to a tank where we can process it, filter it, and then use to flush our toilets and water the eco gardens. Yep, that's about it.
Okay, just to interrupt, we actually gave you a bit more time, so there is about 2 minutes, okay, to your Q&A. If there is any other questions from the judges, you can still proceed. If there are any other things that the team wants to add on, please do. So we have given you an extra 10 minutes.
Can we share our presentation and the video now?
Why don't you all show the video? Yeah. Yep.
Yeah.
I'll just show our presentation video. Is that okay? With my team members, is that okay? I will share this presentation video. Or should I share the video of the...
I think the video will just do.
Share what you think you can manage within the 2-3 minutes, and then share the one that you think that you can show your design the most.
Final video.
I think we can.
Yeah, I will agree to go with the final video.
It's not playing. Is it because I'm screen sharing? I can't play any videos.
You can play.
But
Yeah, when you share screen with the teams, there's quite often it will hang. You try again.
It's not working.
Are you sharing off the net, or are you sharing from your hard drive?
I'm sharing it off the net because I don't have the. I'm not.
Because it takes out a lot of RAM to do the Teams meeting. Then you want to run the RAM to do your off the internet. I don't think most of our laptops cannot manage lah.
Can I take over to share screen instead?
Yeah, sure.
I'll share the other video.
Let me share.
Is my screen visible?
Yes.
Yeah, your screen is visible. Yep.
Okay, I'll play the video now.
Is it just me but there's no sound and it's choppy?
Yeah, it's choppy and there's no sound. Yeah. Maybe one of the members can talk when it's running. Don't do this already. Just let it go.
Okay.
Yeah, because
right.
it's going to be choppy. Yeah. Yeah, y'all can talk when as the video go along lah. Someone, if y'all want.
Yeah. The architects. Do you want to add on to anything?
Yeah, so basically this is a commercial area and we designed to have using step ventilation to cool down the space passively and also in order to reduce reliance on electricity. So the entire space is very open and we try to keep the distance within like 12 parameters so that the step ventilation will be effective within our commercial area. And this is the residential area, and as you can see that they are made of the PVC unit, and we aiming for a high percentage of PVC unit. So other than the balcony and the common area, the rest of the area are of PVC unit, and this is the step ventilation area that we place a glass static opening that we create this pressure difference in order to allow the air to ventilate. Yeah, so this is the rooftop solar panels. Yeah, so to also to be is one of our sustainable feature design. Yeah, so this is our architecture form finding and form finding process. Yeah, so basically we look at ventilation and also some path natural ventilation to create open area and to create a private, semi-private and public space. And using a grasshopper technique, we try to is one of our form finding process. And we eventually derive in PVC unit with brise soleil, tackling the heat and the direct sunlight. And these are some of the PVC module that we have. And these are the final form for our residential area. I think the engineers will take over this part.
Okay, so first we use our CFD analysis to look at the ventilation in and around the building. So this is done with online software. And then next we use Navisworks to check our clash detection between the structural. So we uploaded the structural and the MEP plans. So next we use Microsoft Project, which I think is very common for construction scheduling. So you can actually see how long is our project and which are the precast and the PVC stages. So Navisworks also help us to visualize that construction process. So sonar analysis is for the shadows and how it will cast on the building and on the garden.
This one is the solar radiation analysis. So basically is to try to see what are the how we can face the buildings and to control which areas, for example, residential area will face to the less intensity of sunlight. And we'll use this to identify where to place the solar panels as well for energy generation. Please proceed.
So in our PVC module, we make use of flexible pipings to link two different modules together to allow for a more efficient construction. And also everything is done off-site, and we use just in time to bring the modules on site for assembly. And to assist us with collaboration, we have been using virtual reality. And as mentioned before, we have centralized air conditioning and grey water harvesting. And most of our discussion is done on Zoom. So it helps that we have a virtual reality software to tell each other about our design changes and updates.
Yeah, maybe to add on the IDD part as well. For our digital design part, we just aim to use different BIM software to try to keep to ensure a work sharing platform that we can share our work seamlessly. And some of the that's for example the VR analysis, which all can incorporate into one like Revit file, so that will ease the design process. Then for the digital constructions, we aim to for digital manage fabrications and constructions. We have actually insert the microchip inside the PVC modules. So from the present process project that already done on IDD, there's actually a microchip inside the PVC, so the workers can just scan and upload updates the construction process. And for digital management, there will be one example is remote access to, for example, based on the key performance indications to timely updates, upgrades the facilities as well as repairing. Yeah, that's for the IDD portion.
Okay, I think we got to let you go.
Yeah.
Okay. Yep.
Thank you.
Thanks.
For that team, RV consultants. Okay, the next team before lunch is NYP BCAA collaboration team 3, led by Sean Lee. Is the team?
Yes, good afternoon, judges.
Yes.
Okay, let me share screen for a while. Okay, I'm not sure whether you can see my screen or not. But...
Yes, we can.
Yeah, we can. Yeah, start.
Can see, all right.
Hi, yeah, can I just check a quick one regarding DFMA first? Could you share with us more on the basis for your types of DFMA adoption? In particular, why I saw that you use MET for your DFMA proposal. Why are you using MET as compared with other available DFMA technologies available? If you can share more.
Yeah, sure. I will push this presentation on to Shukri and Coco.
Hi, I'm Coco. Can you hear me?
Yes.
Okay, so for the DFMA, right, by using MET, and steel hybrid, right? Construction is to form a network of structure and like services for the prefabricated architecture elements to attach to it, so that the architecture elements are not fixed permanently and can be easily reconfigured to suit changing needs.
Okay, because there are a lot more other cheaper DFMA technology that is also easier maintenance. For example, you have concrete, PPDC, or even steel. So what is the main reason why you are choosing MET, which might have some additional fire maintenance issues and also cost considerations? Can you elaborate?
Because using MET, right, promotes reforestation as well. So at the same time allows for efficient and sustainability construction.
Can I add something on? So we are actually not just using MET, we are using MET and steel hybrid construction so that we can form a grid-like network structure. This is not fixed permanently and can be easily reconfigured to suit changing needs. In a way, it is flexible such that, like when you want to expand or add on, it will be much easier because we have to we negate the need for you to include additional and adding on structures. Yeah.
Okay. Yeah.
Okay. Hi, Lucia. Maybe in terms of sustainability, besides doing solar analysis to maximize your rooftop for solar panels, is there any other strategies that the team has looked into for energy efficiency?
We have also explored using ventilation, such that in a way the building is a form of stacked ventilation, and that is also applying. Yeah. Can you show the slide?
Yeah, I think Leon has control of my slides. Okay, yeah.
Yeah, this slide here, as you can see, it's a form of stacked ventilation whereby the ventilation can travel through. And also we included like greenery to make it breathing much easier, and we are integrating that with the fields outside and also trying to pay a tribute for the old field that once stood here.
Okay, and any other aspect of technologies that you're looking to really like maximize the energy efficiency of the building itself?
Besides from the solar panel?
Yeah.
The roofing. The roofing here, not only does the solar panel not only does the roof act as a platform for the solar panel to maximize the solar energy, it also acts like a shelter to prevent the sun from directly releasing through the latent heat of the sun to like the living areas, and that will cause an increase in temperature. It also acts as a shade, and yeah. Can I add something on about the MET? It is in line with our theme of wanting like an orchard, and that hence we have to use timber. Also, it also gives warmer vibes and it pushes the boundaries for the future of architecture itself. Yeah.
So was AR or VR used to visualize the design or assembly process or work sequence?
In that case, there'll only be AR lah, but we only included that in the video that we sent to you guys.
Okay. And how do you use it to optimize your design?
Sorry, second.
How did you use it, the AR, to optimize your design? You did it, right? But how did it help you?
Or it's just a better visualization on the volumes on site and whether it sits well or not.
So we can kind of visualize what is where is what. Yeah.
Right.
Did you adjust your design after that? Like, did it help in, or just to see only, do for this?
Just for visual purpose only lah.
Okay.
And we also adjust the scale of the towers lah.
Also, I don't know if this is related, but we use the messing to like visualize. We use the messing to like visualize which structures best can make the which positions can best make use of the solar panels to use for solar power efficiency for the rest of the building to get electrical energy lah. Like as you can see here, we tested multiple roofs. Yeah.
Okay, thank you.
Thank you.
In terms of the collaboration platforms, you have mentioned that you used Google Drive. Okay, it is just for sharing purposes, but what were your challenges in terms of using Google Drive? Because I see that you have used Navisworks for coming out with your coordinated models, so there could have been a lot of revisions in the model. So how did you manage those revisions appropriately using Google Drive? And would it be possible for you to share how did you use this Miro platform that you have done? Was it for project planning purposes? Or did it directly reflect in terms of how you came out with your project schedule?
There's a slide. Hang on, I'm moving to the slide.
The Miro board is mainly for just
Concept.
updating the group on our progress.
And it was to further develop the concept because we could not like meet each other in person.
It's more for like collaboration and communication, like for like our own group comments.
So as you can see here, like we initially came up with the concept by using charts, information, what we want to build upon, the design concept we wanted to implement. Yeah, and then we included like drawings, sketches, messings in there. Yeah. Then for the Google Drive, like we communicated in real time using Zoom so that we can make like necessary changes on the host module of the Revit folder, Revit file itself. And then when we are done with like the necessary changes, we will share it to the engineering side, which also has access to our files, so they can just download and use it from there.
Were there any specific challenges because you will have to manually update all the revisions that you are coming out with once you do your coordinated model?
Actually, the only challenge we face with Google Drive is the lack of space given lah. There's only 15 gigs, so yeah. Then we share quite a lot of information also as well.
Yeah. And also sometimes they may not know when exactly we are going to update, so we have to constantly communicate with them so that nobody like is at a loss of what to do when. Yeah.
And yeah, by the way, can I add just one more thing? We initially wanted to use BIM 360, but due to licensing issues, right, we are not able to use it lah. That's one of the constraints also as well.
All right, noted. Yeah, if you would have used any commercial platform, at least a trial version, you would have negated that issue that somebody just mentioned about the auto notification portion.
Yeah, very sorry about that. We didn't notify them.
No. It's okay. Just asking the challenges. Yeah, that's all. Thank you.
Thank you. Judges, any other further questions?
Okay, let me just a couple of things. the mark here, the ultimately the final massing that you guys came up with was basically 2 slab blocks, which basically vary in height, and you basically opted for, I think, a roof feature. In one of your perspectives, I saw a roof feature where the roof projects significantly beyond the building footprint of the towers, that they vary in height. I also noticed that you guys, well, first of all, is there any reason why you opted for these 2 slab blocks as a massing?
This comes down to the initial concept whereby we took inspiration from the way the CDs were stacked in this shop called His Majesty's Voice, which was a core attraction of Orchard Road itself. It basically defined Orchard Road. Yeah. And from there we developed the initial pattern of how a CD was stacked. And from there we randomized and built upon that idea.
It's a bit arbitrary lah, because Orchard Road has many layers of history. I mean, we got some other group who went all the way back to the to the days when it was a Chinese cemetery. Then some groups went all the way back to when it was orchards, and I guess yours is more recent history of. So a bit arbitrary lah. Okay. The other thing is because, okay, you guys have all of these solar panels which are basically sitting on the roofs, and the roofs vary in height. And I saw one of your simulations when you basically did the shadow analysis. I think I'll just not frame it as a question. I'll just say it as a comment. I think because the buildings vary in height, and during different times of the day, the parts of the building which actually, can you stop right there? Can you go back to the previous one, the previous slide? The previous slide, yeah, the one with the red markings, yeah, this one. If you basically take a look at, no, the other one. Yes, this one. Okay. If you take a look at the diagram on the lower left-hand corner, I think you can see it quite clearly there. If you actually do the analysis of the way sun basically lands on these PV panels which you are sitting on your roof, because of the variation in height, you cannot extract out the optimal performance in terms of catching the sun, because you end up with situations, different times of the day, different times of the year, where your building massing is basically casting shadows towards each other because of the variation in height. I think maybe that was there might have been a good opportunity to maybe use some IDD automation technologies to basically see how you can basically maximize being able to catch the sun and avoid all of these casting of shadows onto each other. Perhaps still being able to retain your stack CD concept or whatever concept. Then I think I will probably also find myself going back to the question of MET, similar question to the previous group who also used MET, adopting it to a high-rise configuration. Not sure if you guys have reviewed the fact that timber is an inherently combustible material. So if it's using it as a main material for a high-rise building, if you guys have taken any measures, done any provisions to cater for the combustibility of timber as a material. Our real life experiences have given us a few challenges dealing with the authorities pertaining to this. So I'm not so sure if you guys have as well as thought about this.
Actually, the MEP site has thought about this and installed like fire hydrants and fire sprinklers. If I think I would pass it to the MEP who are better specialized in this. Yeah.
Yes, can you hear me?
Yes.
Yes, for the fire protection system, we use the fire hydrant and the fire sprinkler to achieve the purpose of firefighting, which is a normal one.
I'm not so sure that's sufficient, but okay lah.
All right,
okay.
have overrun
Okay, just one
into time.
one last.
Yeah,
Okay.
any more?
Okay. No, go ahead. Yeah. Junida, you can go ahead. Yep.
No, any other questions from the judges and the team?
Nah, it was just a comment to follow up only. That's all. Yeah, it's fine. Yeah.
Okay, thank you, team. Team 3, right? Team 3 from NYP and BCAA.
Yeah.
All right, thank you very much.
Right.
Thank you.
So we have come to the end of the AM2 session. We have overrun quite a bit. So when we report back later on after lunch, that will be about, let's start at, I don't know whether you want to have a full lunch hour or 2 o'clock or 2:15. What's
I think
best for the judges?
for me, 2 o'clock is fine, or even
Yeah,
earlier.
2 o'clock's fine for me. Yeah, 2 o'clock or yeah, 2 o'clock or slightly. Yeah, it's fine with me.
2 o'clock
Okay,
or
let's
earlier.
yeah.
Depends on the rest. Yeah.
I'm okay.
I'm okay.
2 is fine. Thanks.
Okay, Ken.
Okay.
We
Alright.
will meet at 2. The rest, I will leave this link open, but I will end the recording. We will meet again at 2.
Okay.
Okay.
All right.
Okay.
Thank you.